We then create a brand new thread, and then we run this 3-step pattern. This pattern can be reused for any situation. Diagnose the situation, generate the solution, execute the solution. All the greatest developers I know and have worked with have really tight feedback loops. You want to keep the distance between you and your next iteration as short as possible. You can use LLMs to autocorrect any system that outputs concrete results. Put it back into your system just like we did here, add a little bit more context, you're going to get some rich, self-correcting agentic systems. I think it's risky to go all in on GPTs and the Assistant API. LLMs are the new oil. That's been made pretty obvious, but there's going to be a massive gold rush. There is a gold rush happening right now to build out all the GPTs, right? GPT for everything. I recommend just taking notes, sitting back in your chair, skipping the obvious use cases, and focusing in on very niche problems. What if you could use the new Assistants API with GPT Turbo to run your software business? Even if you could only automate one segment of your business, wouldn't that be amazing? That's a load of time and cognitive energy saved. I think this future is not far off at all. In this video, I want to give you ideas on how you can use GPT tech to automate feedback loops in your software. To explore this idea, we're going to use the Assistants API to automatically correct errors in our Postgres data analytics tool we've been building over the series. This is the 9th and second to last video in the series. Next week, we officially launch Talk to Your Database right here exclusively on YouTube. This is exclusive for you and I to help us seamlessly talk to our Postgres database in a new way. We built the product right here from scratch on the channel over the series on top of GPT tech. It's going to be completely free, so feel free to sign up. Let's add a self-correcting assistant to our Postgres data analytics tool. Let's look at where we are right now. In the previous video, we built out 3 front ends. We experimented with Aider to rapidly prototype our front ends. We have a simple user interface where we can type in natural language and get results out of our Postgres data analytics tool. If we open up VS Code, we can see that we have 2 applications running. We have our front-end Vue application, and we have our Flask application that can be deployed to Vercel or any other backend. Let's go ahead and just run a natural language prompt so you can see where we're at. Select users that submitted job feedback with a rating less than 3. Let's go ahead and let that run. You can see here we have our prompt, we have the results, and you can see the SQL query that was generated. So we're getting distinct users, enter join job feedback, rating less than 3. If we open up Table Plus, you can see that that query is going to give us all of our ratings that are less than 3. So that's fantastic. That's the high level of the application. Before we start digging into how we can make our backend self-correcting, let's boot up Aider and let's just make some improvements to our front end. I really like this idea of having an agent working for you in parallel while you're getting something else done. So in a new terminal, I'm going to CD into our Vue.js front end. I'm going to boot up Aider. I'm going to add the app.vue.js file that you can see here. And this file is really simple. You can see here we have the icons, we have the headers, we have the input, and we have our prompt results here. The JavaScript is simple as well. We have our prompt, we have our prompt results, and then we have this sendPrompt function which sends the prompt that we enter in the input field to the backend to generate our SQL and run it against our database. The result then gets parsed and added to our prompt result list. I'm just going to run a quick prompt here, add the assets TTYDB SVG logo next to the Vue logo and link it to talktoyourdatabase.com. So this is pretty cool. This is going to run. It's going to add the logo. Just want to show this off a little bit. I think pair programming is really going to take off over the next year here. So I want to get you guys into it ahead of the curve. Let's see how that looked. Awesome. So that automatically updated. We have the black background here. So let's go ahead and update the background to black real quick as well. Update the logo image backgrounds to black. We just want to make that a little more consistent. Sweet, so that update came in live. We have written 0 lines of code and we have changed 2 things already. Let's go ahead and throw one more prompt at this and then let's switch our focus to our self-correcting agent. Add a created date to the prompt result. Create a computed property, sorted prompt results, the rows. I'm just gonna let that rip and we'll come back to this. So let's talk about what our application is doing right now and what we want it to do. So right now our application looks something like like this, right? We have our Vue.js front end. We also have two other versions. We made a Svelte and React version. Check out the previous video to see how we built that. But we have a front end version here that then makes an HTTP post to /prompt just like we saw. We then have our data engineering team that generates SQL and runs the SQL, and it communicates with our Postgres database to pull in the tables it needs for the prompt and to also run the SQL, right? After that runs, we have two different kind of states that happen here, but they both result in just returning to the front end, right? So that's the current state of our application. We'll walk through the backend code in a little bit. Here's the application that we're going to build out right now. A very similar version, but as you can see here, a big difference. If we have an error, we come into our self-correction assistant and we run these 3 steps, aka 3 prompts. Diagnose this SQL query. Based on your diagnosis, implement the resolution, and then run SQL. After that happens, we then return to the front end. So we're getting 2 shots here at generating a result. Our self-correction agent is going to use the new OpenAI Assistants API. So that's what we're going to build right now. Let's quick jump back to Aider to see if it's implemented those results for us. Okay, sweet. So we can see we have created. We can see we have a new computed property, sorted prompt results. We can see that updated this section for us. And we can see that we have created now getting added to the result. This is awesome. I just love showing this off that, you know, while we're working on something else, we can have an assistant running for us, writing code for us. Just to give a sneak peek of where the channel is going in 2024, we're going to be building out autonomous agents that run alongside us, just like Aider, and fulfilling and building software for us while we're doing something else. Aider is just the first step. It's a really important step, all built on top of this amazing GPT technology, of course. So I'm just going to make another change here. Let's say input with 300 pixels. Awesome. Let's let that run. And let's go to the backend. So in the current version, we have a simple Flask API with a /prompt route. We have some CORS stuff happening here, so we can run this against localhost. We're opening up our Postgres agent instruments, which you can just think of as state and functions for our application to run with. We have our Postgres database right here. We pass in the database URL. We're pulling out the prompt from the request. We're gathering similar tables. We're updating our prompt with our similar tables that we just pulled out of our SQL database. We're then setting up our GPT LLM tools, and we're running 2 prompts here. One prompt here is generating SQL, the other is running it. We then load back out our results from the files saved by running our run SQL function, and then we return with our response, and that's how we get the results here you see on the front end. We can see that our input size did increase. That's awesome, and that's the current version of our application. Now let's look at a natural language query that's going to fail. Real quick, I want to get some space in here, so I'm going to ask Aider to generate that for me. While we talk about a failing query, I'm going to open up VS Code. I'm just going to say input add space below. Okay, so let's look at a query that's going to bomb. So get all users with job that have completed status. Job is not a table. Now when this runs, we're gonna get back an error from the backend. As you can see, we got an error here that looks like a CORS error, but it's actually a database error because we're trying to look at a column that does not exist because we're looking at a table that does not exist. If we open up Table Plus, we can see that we have a jobs table, not a job table. So this is a small kind of contrived example, but it's going to show off how agentic software can be self-correcting. So we have that error. Normally I like to code through this and make the experience a little more interactive. For this video, I'm just going to Thanos snap this coding session so we can discuss right away. I'll see you on the other side. So we've implemented our brand new self-correcting assistant. Let's look through what's changed. So you can see here we have a brand new function at the top, self-correcting assistant. Let's look at the application flow that leads up to that first. So in the prompt function, just as before, we're gathering tables, we're putting together a prompt, we have our tool, but instead of just returning, if we see a Postgres error here, and the Postgres error here has just been aliased, so you can see here we have import error as Postgres error. If this happens, we're going to run our self-correcting assistant. We're going to pass in the DB, our state and our functions, the tool with the run SQL function, and of course the error. All the code below is exactly the same. So let's hop into our self-correcting assistant and see what it looks like. The first thing to do is roll back our database commit. Since it's stuck in a failed transaction, we need to roll back. Then we start building up some state for our correction agent. We grab all of the table definitions from our Postgres table. So we're going to get all the create statements for all of our tables. We're going to load a file path that we can save that to. We write the table definitions to a file. We then read out the SQL statement that was run. Then we start building our prompts. You can see we have our prompts in 3 steps here: diagnose, generate, and run. We then build a Turbo 4 assistant. Turbo 4 wraps the assistant API. If we come to Turbo 4, you can see we have a nice clean wrapper class for all of the OpenAI Assistants API function calls. We built Turbo 4 out in the previous video. I definitely recommend you check that out. People are getting a lot of value from the Postgres data analytics tool and the code base. The link to this code base is going to be in the description. Feel free to check it out. Every single video in this series links to a specific branch in the code base. So you can time travel to each step and parse out just the information you need. So that's Turbo 4. If you want more details into the implementation here, check out the previous video where we built out Turbo 4 from scratch. So now that we have our Turbo 4 assistant and we have our table definitions written to a file, we can use the Turbo 4 assistant to upsert these files. So it's going to create or update this file that contains the table definitions for our Postgres database. We then kick off our Turbo 4 assistant, and this is the meat of it. I'm really excited about how Turbo 4 has turned out. It allows us to jump in here and do really powerful things like this. So the Turbo 4 assistant is what enables us to run back-to-back prompts with tools, without tools, with files, without files, run validation on it, look into the messages that our agent system is having, so on and so forth. You can see here it's broken down in a nice clean fashion. Turbo 4 is a building block that I have and will be using for a while. It reads so cleanly and so nicely thanks to its chainable functionality. Let's walk through this top to bottom. We set instructions, we enable retrieval so that we can read from files. We enable our tools, and you can see here our tool here is the same tool that was passed in. We have the run SQL tool here. This is just a simple class that wraps name, config, and a callable function. And you can see here we're passing in the SQL tool config and our run SQL function. Okay, so that enables our agent to run these tools. We then create a brand new thread for the messages to run on top of, and then we run this 3-step pattern. This pattern can be reused for any situation. It works like this: diagnose the situation, generate the solution, execute the solution. So in step 1, we're passing in our diagnose prompt with our file ID. Remember, the file ID is the table definitions of our SQL table. So now, using RAG or whatever implementation OpenAI has figured out, it can reference our SQL table create statements when it needs to, if it needs to. The diagnose prompt looks like this, right? Given the table definitions.sql file and the following SQL error and the SQL query, describe the most likely cause of the error. Think step by step. Then we're passing in 2 capitalized references here. We have the SQL error, which will of course reference back to this variable. And then we have the SQL query, which of course references this. And just as we're here, we have the generation prompt, which says, based on your diagnosis, generate a new SQL query that will run successfully. And then finally, we have our same run prompt that we used before. Use the run SQL function to run the SQL you've just generated. Okay, so let's hop back to the chainable functionality here of Turbo 4. We add this one message and then we run the thread. So we don't need to give any more information here. We're running that one step. So you can imagine we kick off, a ChatGPT chat that's running right now. And now we're going to get a response after this finishes, right? So we run everything up to this point. And now we're going to run our spy on assistant functionality. Again, we built this in a previous video 5, I think, where we added spying functionality that allows us to generate a clean chat file so that we can monitor the success of our application. So that runs here. And you can see here, I'm running this spy on assistant after every step. I want to make sure we have logs to look at no matter if there's a failure on step 2, 3, or near the ending, right? We want to always have that chat file updated. We then run step 2, generate, and you can see here, of course, we're passing in the generation prompt. So that runs another thread run. So you can see here we have that run thread running there, and same thing, spy on assistant, and then finally execute. So you can see here in the run thread, we're actually going to pass in our toolbox, which has our tool, and we're just passing in the name. And this is going to activate and say, hey, you have this function, I want you to run it. And the great part about the Assistants API is that it has the context of all the previous information that's been running here in the thread, right? You can think of this like the thread contains all this information, and it's running, and of course also has the file. So it really looks something like this, right, with our file right here, right? So it has the context of the entire file, and that's super awesome. Let's go ahead and back that up. So, and then at the end of here, we're just running some validation. We're running another chat file log, and then we want to get the cost of everything that just happened there based on the chat file, right? So that's everything. So this is our brand new Turbo 4 Assistance API wrapper self-correcting assistant. So let's run this, right? I've just been talking this whole time. Does this even work? Let's go ahead and see. So we have the server running and we have the front end running. That's great. Let's hop back to the application. So let's go ahead and run that exact same prompt, right? Let's get all users with job, right? Invalid table that have completed status. So I'm gonna let this run. Let's hop over to the server and let's look at what's happening here. So, okay, so it's got the base prompt in there, right? And add some space here so you can see this. Okay, so you can see there's the error, right? And now right away, our assistant just got kicked off, right? So it's saying, here's the error, here's the query. Now I'm gonna run thread. Right, so it's starting one of the threads. You can see the make thread up here. And okay, so basically your diagnosis, generate a new SQL statement. So it's already on that second. Also, it's on the third. So you can see run thread, add message, run thread. There's a response. So let's go ahead and look. So get all users with job that have completed status, right? And you can see here, self-correction. We have jobs. And you can see, of course, we got an actual result. And this query looks good, right? So parent ID where j.status equals completed. If we hop over to table plus, so here's job, and you can see there's a completed status. We can just go ahead and sort that and see we'll have, some amount of results there and the respective users. So awesome, that's self-corrected. So let's go ahead and see what exactly happened there, right? Let's go ahead and copy out this run. Let's move this to a file and let's look at this top to bottom, right? So there's the base prompt, get all users with job that have, completed status. You can see there, let me change the file mode, just go to plain text file, great. Okay, so you can see here, we received the error, right? So, and then you can see here it's saying running self-correction team to resolve. And then here's the exact error, right? We're loading table definitions here. And then you can see we're starting to run our functions. So at the top of every one of the Turbo 4, let's open up Turbo 4. At the top of every one of the Turbo 4 functions, I have this kind of debugging pattern where I'm saying, I'm basically just printing out the name of the function. And, so you can see make thread right there. You can see add message, right? I'm dumping that right at the top just so it's easy to read and easy to see. So if we just do a quick regex for this pattern, you can see that coming up over and over. So you can see we're upserting this file, right? So there's our table definition file getting upserted to the OpenAI Assistance API. You can see here we have our existing files there, found existing file, and then it's checking it already exists. No need to update it. Great. So now we're running self-correction assistant. We're setting the instructions. We're enabling retrieval, right? And if we hop back, you can see here set instructions. That's exactly what's happening here. So it's set instructions, enable retrieval, equip tools, and you can see that reflected here, right? Set instructions, enable retrieval, equip tools, make thread, add message. We also have the message getting printed out here, right? Given the table, here's the SQL, right? This is just our diagnosis prompt. So that's happening. And then we run that thread, right? So OpenAI does a bunch of work here for us. And then we run to the next message, and then the next, and then the next, and then the next, right? So this is good. Let's look at our actual chat logs that we're shipping out right here. Thanks to our Spy on Assistant call, we can see that in agent results here, we have our entire agent conversations. Earlier in the series, when we're using AutoGen, we have this between several different agents. Right now, it's just from and to us. So that's nice and clean, but you can see here, top to bottom, it's running our diagnosis prompt. And then this is where all the magic happens, right? So to the user from the assistant, so our assistant's telling us, there's no user ID column in the jobs table. And so this is really fascinating. It actually pulled an invalid variable instead of the invalid table name. So I was thinking this would come in and actually just grab, job and not get the S on the jobs table, but it actually did find that. So that's really cool. But the problem here is that it referenced this user underscore ID, and user underscore ID doesn't exist, right? If we open the jobs table, we can see here we have parent user ID. So this is actually really cool. I didn't predict that that's what this would attempt to fix, but it kind of just proves the point that when you're building out these complex systems, you can use software agents, you can use LLMs to self-correct problems that you couldn't even foresee, right? We literally just saw that happen I was, trying to create this environment where one error was going to happen on purpose, obviously, but something else happened entirely and it still caught it, it still corrected it, right? So you can see here, we have user ID and it self-corrected that to parent user ID, right? So really fantastic stuff. But you can see that all in the message, whatever LLM systems you're building, doesn't matter what tool you're using, make sure you have really good logging. All the greatest developers I know and have worked with have really tight feedback loops. You want to keep the distance between you and your next iteration as short as possible. That's where great debugging, great logging, and great success monitoring really comes in, even if it's something as simple as a chat message just like this, right? No one said it needed to be complex. So that's great. So you can see here, we're then building that self-corrected query right here, and then we run that next chat conversation based on your diagnosis, generate a new SQL query that will run successfully. The agent looks at this, it sees that we need to build this statement, and then we're saying run this exactly, right? So use the run SQL function has been successfully run, and then classic chat stuff. If you have any further requests or need to see the results, please let me know. So that all ran there. That's fantastic, and it was all thanks to our really kind of clean, really simple to reason about Turbo 4 Assistant, which is a wrapper around OpenAI Assistant's API. Link for all the code is going to be in the description. This will help you get up and running quickly if you're not already using the OpenAI Assistant's API. And if you are, maybe it'll help you, create and maintain. You can use this to, build your own patterns, tweak it to your liking, whatever you need to do. I wanted to share this with you to help you on your engineering journey. So this is fantastic. Let's talk about some pros and cons of the Assistant's API, a little bit of strategy. Assistant's API, let's talk about it. So the biggest win here is memory. With the combo of GPT-4 Turbo, file uploads with RAG or whatever OpenAI is doing under the hood, we don't actually know, along with tools, makes the Assistant's API a nasty, amazing combination with both short and long-term memory, right? The fact that we can upload files here, and we can go ahead and look at this agent, right, on the API. SQL self-correction agent. The fact that this can hold files, can use retrieval, and it can also run functions, makes it incredibly powerful, right? Like, especially with a clean wrapper like Turbo 4, this is a really, really powerful tool that allows us to basically create arbitrary agents to do anything. Again, specifically thanks to the long-term memory. The real innovation is the combination of long-term memory and the tools. The fact that we have access to the previous chat conversations inside the threads and the capability to start new threads is also a really fantastic tool at our disposal. Theoretically, I think we should all be building use case specific agents that ultimately replace ChatGPT, right? This is likely what OpenAI saw, and that's why they put out the GPTs. A lot is just happening here magically under the hood, right? I have 15 lines of code. Obviously, there's a decent amount happening in the wrapper, but just 15 lines of code after the abstraction, that's pretty amazing. To build something like this before, you'd have to build an entire graph database that understands SQL really well, multiple models to be able to self-correct like this in 3 prompts, basically, 3 LLM calls is really extraordinary, right? So there's a lot of good happening here. Just want to highlight once again, the biggest win here of the Assistant's API is the ability to create extremely use case specific assistants with your knowledge base, right? I don't think this is new information. I just want to highlight that that's really the key here. And that's like when you're thinking of use cases and when do I use the assistant, that's what you should be thinking. Do I need a ton of memory? Do I need very use case specific knowledge where I can upload files? And also, do I need some type of function calling capabilities? I think with any agentic system, like many of the agentic systems we're going to be building here on the channel, I have so much exciting stuff to share in 2024. I really can't wait. But with any agentic system, we're going to need all of these components, right? And I think OpenAI has correctly identified that, likely by listening to us engineers, but also by being engineers themselves and really tackling this problem head on. We have this really new fantastic idea of the LLM OS. Highly recommend you watch this entire video by one of the OpenAI kind of key creators, key builders, key researchers. I think it is really telling about where things are going. But I think Assistant's API is probably one of the first it's a heavy step and it's a kind of a big step, but it's a really great step at putting all this together so that we can build our own assistants with enough capabilities to get the job done. It's going to be clunky, it's going to make a little noise, it's going to cost a bit. That actually is a perfect segue to some of the negatives, right? So what are some of the negatives of the Assistants API? This is going to hurt a little bit, right? If we look at the pricing here and we look for retrieval Assistants API, it's not exactly going to be cheap. The big problem is it's going to be pretty hard to scale this at this cost. It's good. I hope it continues to come down. I really hope OpenAI continues to really ship and stick to that mission of making it really cheaper, handing off all the gains to the developers so we can build a really rich ecosystem for and with OpenAI. But you can see here, this is going to stack up. Another issue I see is limitations around how many agents you can create, right? How many custom agents you can create, how many different versions of these you need to have live to serve all of your customers, right? Let's say you have 1,000 customers operating on your application every single day, right? Can these agents support that type of throughput? I'm not sure yet. Something that I hope to experiment with in the future. So I'm curious about that. Is the Assistants API sustainable? If you look at the logs for one of these OpenAI calls, right? Convert this NLQ into a S and create it after. Okay, just a random query, just making something up. But here's my point, right? Is it really sustainable to be making API calls like this per user, right? This was just a single run. And in our example here, we ran 3 thread runs happening here, right? So we have essentially 3 times these, requests coming in and out of OpenAI. That's a lot. And this is going to slow down your application quite significantly, right? Even backed by one of the best AI infrastructure providers, Microsoft on the Azure stack. As you know, they have a lot of information coming at them right now, coming at their servers. If anyone can do it, it's them for sure, but definitely something to think about. Another really important point, we're adding a lot of risk to our application for several reasons. First off, we're depending on OpenAI being up. As we see some days, OpenAI is not running properly, right? The API is bouncing. The API is not functional. This is something I'm thinking about for Talk to Your Database, the full productionized version. I'm going to have to build in some type of error message that just says sorry, OpenAI API is down, so the app is down. And that type of dependency is obviously really bad, right? That's risk manifested, in your application. It's a key spot to have backups, to have, more brute force technology, just raw code. Imagine that, just writing raw code to solve problems. Definitely, there's a huge space for that still. We can't fully switch over to this LLM technology. Obviously, it's not quite there yet. It's not quite as sustainable as we wish it was yet. But of course, it's getting there. And then last thing I'll say here is, with the Assistants API, there's a bit more state to manage, right? You have to manage your tools. You have to manage your files. And you have to manage, your reporting functionality. So, something else to think about there. All in all, I think it's risky to go all in on GPTs and the Assistant API, specifically for non-niche use cases, right? LLMs are the new oil. That's been made pretty obvious, but there's going to be a massive gold rush. There is a gold rush happening right now to build out all the GPTs, right? GPT for everything. I recommend just taking notes, sitting back in your chair, skipping the obvious use cases, and focusing in on very niche problems that you're in a unique position to solve, that you have unique knowledge, you have unique data, and you have the ability, and you're watching channels like this, and you have an advantage here where you can build out a very specific use case extremely well using Assistants API, using GPTs. I think the real value is going to be generated kind of in the background at some of these companies. Given that Assistants API is stable enough, a custom Assistant API is going to be able to do a ton of work and create a lot of value. I'm going to say that, just to kind of call that out, you want to be using the Assistant API only if it fits the problem that you're trying to solve well. For instance, for Talk to Your Database, am I going to build something like this out? Definitely, right? I love this idea of having a self-correcting agent, self-correcting assistant, but is it going to be on top of the Assistants API, firing off 20 HTTP requests to OpenAI? Probably not. I can probably do this with a couple prompts, maybe 3 prompts, right? I can replicate each one of these prompts, just make 3 requests, fire the tool, and be done with it. Also something to think about, don't overkill it with the Assistance API. For most use cases, Assistance API is overkill. So that's it, kind of a deeper discussion. Really wanted to dig into the Assistance API and talk about this use case. I highly recommend you try to build something like this out, some type of self-correcting pattern. This is really powerful and it can be used for several things. Self-correct code generation, correct and improve email generation, language syntax, spelling, formatting. Basically, you can use LLMs to autocorrect any system that outputs concrete results, either success or error, right? And if you can take that error, put it back into your system, just like we did here, add a little bit more context, you're going to get some rich, self-correcting agentic systems. That's basically it, guys. Thank you so much for watching. If you made it to the end, definitely like, sub. Really appreciate you being here. 2023 has been really incredible for us. The channel has really taken off, but things are going to get a lot crazier in 2024. The things I want to build after we roll out Talk to Your Database, it's going to be really exciting. But yeah, once again, next week, Talk to Your Database goes live. It's going to be a self-contained application where you can provide feedback right in the application and really be a part of the direction of Talk to Your Database. I'm really big on user-led development, so I'm going to take that to an extreme as much as I can here and put everything I can inside the application so that we're working and building on it together in some type of way, right? So feel free to sign up for this. This goes live next week. What's next? I need to focus all week basically on launching this, making sure it's as great as possible for you. The 10th video will likely be a really cool demo of this application in the productionized environment. We've been working on kind of toy versions, but in the background here, I have put together what I think is going to be a really kind of fun, interactive, simple, functional application that allows us to interact with our database in a brand new way. So again, feel free to sign up for that. We built it from scratch on the channel over the previous 8, now 9 videos. Like, sub, hit the notification bell so you don't miss the release. I'll see you next week.